All right, young true believers, we're going to finish up chapter 8, formal fallacies and fallacies of language. But there is a really important fallacy that I wanted to talk to you about in the last chapter, and I forgot that, because it's not in the 12th edition of the text. It was in previous editions. For whatever bizarre reason, Warren Parker took it out. But anyway, it is an extremely important fallacy, one we need to talk about. That's rationalizing. Rationalizing is an attempt to justify behavior that we know cannot be morally justified. So, there was a former colleague of mine at the college who will remain nameless, who we went to grad school together, so I've known him for a long time. He would routinely engage in risky behavior, right? And when I confronted him with this, he said, as long as you're a heterosexual man who's not an IV drug user, your chances of contracting AIDS is virtually non existent. So you don't need to worry about me. I don't need to use condoms. That is rationalizing. That's a premium example of rationalizing. So beware of that fallacy. I don't know, again, why Moore and Parker took it out of the previous of this edition. It was in the previous editions, but it's an extremely important fallacy. All right, so back to chapter 8. On page 229, we'll see confusing contraries and contradictories, right? So a pair of claims that are exact opposites of each other are contradictories, and that means they never have the same truth value. So, for example, the opposite of nunnercarp is not uh, carp, right? The opposite of nunnercarp would be summer carp, right? Um, Two claims that cannot both be true but can both be false are not exact opposites. They are contraries, right? Nunnercarp and carp is a kind of fish, in case you were wondering, are contraries, not contradictories. And as Moore and Parker note, two terms, alive and dead, for example, may seem to be exact opposites of each other. That frog isn't alive, then it must be dead. But that does not follow about just any old object, because a rock cannot be dead by virtue of the fact that it was never alive. So do not confuse contraries and contradictories. Consistency and inconsistency. So, gang, these two concepts get mixed up. A pair of claims is consistent if it's possible for both those claims to be true at the same time, right? So a pair of consistent claims would be something like it's raining and it's a Wednesday, right? It's possible for them both to be true. A pair of claims is inconsistent if it is not possible for them both to be true at the same time. So it's raining in San Jose, California, and it's not raining in San Jose, California at the same time is an inconsistent statement. It's not possible for both of them to be true at the same time. So the reason this is brought up is because politicians, many people, but especially politicians, are often accused of flip-flopping, right? Changing their minds. Well, there's nothing wrong with changing your mind, right? If you hear a better argument, you're allowed to be, regardless of what your station is in life. If you hear a better argument, you're allowed to change your mind. I mean, that's just a mark of rationality. That's intellectual honesty. But you can't claim that the same thing is and is not the case, because that's inconsistent. All right, miscalculating probabilities. The first example of this is what's known as incorrectly combining the probability of independent events, right? So sometimes people make a mistake when they combine the probability of unrelated probabilities, right? And so the example here is Bill's chances of becoming a pro football player are 1 in 1,000, and Hal's chances of becoming a pro hockey player are about 1 in 5,000. So the chance of both of them becoming professionals in their respective sports is about 1 in 6,000. But that's actually not what you do, right? To find a probability of both Bill and Hal becoming professional athletes, you multiply 1 1,000th times 1 5,000th, and that gives you 1 in 5 million, right? That's how you calculate that probability. Next fallacy, very common, very dangerous, the gambler's fallacy, right? A common and seductive mistake that happens when we don't realize that independent events really are independent, right? So for example, so suppose someone says the last 3 coin flips have all been heads, so the next coin flip is more likely to come up tails. While it is true that 4 heads in a row is fairly unlikely, that's 1/2 times 1/2 times 1/2 times 1/2, which gives you 1/16 or 6.25% of that happening. A 6.25% chance of that happening, right? Once the first 3 heads have come up, the odds of the fourth coming up heads is still just 50%. It's 1 and 2, right? When dealing with independent events, past history has no effect, right? So don't be like those elderly people that you see in Vegas and Reno, assuming that because the machine hasn't paid out in the previous 20 pulls or previous 20 tries, it's going to because it's due. Past event does not influence the future. All right. And again, when you're dealing with independent events. Overlooking prior probabilities. This occurs when someone fails to take underlying probabilities into account. So here's the example. Bill is the best football player in our high school, and Hal is the best hockey player. So it appears that Bill's chances of becoming a pro football player and Hal's chances of becoming a pro hockey player are equally good. Now, what is overlooked here is that the prior probability of someone's becoming a pro football player is greater than the prior probability of someone's becoming a pro hockey player. So now you can see what we mean earlier by everything else being equal. Bill has a 1 in 1,000 chance to play pro football, let's say, assuming he has the same chance as any other player at his level. But if Bill were a high school All-American, that would substantially increase his chances, as would be the case if he were recruited to a big football school like LSU or Ohio State. That would significantly increase his chances of playing pro ball. All right. Now, the next fallacy is the faulty inductive conversion. And this one's it's a bit weird, but we'll take some time. So information about the percentage of A's that are B's does not in itself tell you anything about the percentage of B's that are A's. So those who think it does are guilty of the faulty inductive conversion fallacy, right? So here's the example. Most pro football players are men, therefore most men are pro football players. Now you can instantly see what's wrong with it. Most men are not pro football players. Here's another example. Almost everyone who has Alzheimer's disease once ate carrots, therefore eating carrots makes it more likely that you will get Alzheimer's disease. Just does not follow, right? So, gang, that is the end of our section on fallacies. After this, the course becomes a little bit more abstract and a tiny bit more difficult, but it's nothing that you can't handle, right? So, I will be back on Monday, and enjoy your weekend.